So what's all the fuss about James Webb Telescope anyways? Are you tired of shuffling through long videos and still not getting a clear answer? Well, me too. Welcome to Walker Talks. Today we'll attempt to simplify everything James Webb Telescope and give you the benefits in a nutshell. For starters, James Webb Telescope will be the successor to the Hubble telescope, which has been widely successful over the years. Main difference being Hubble telescope can view visible light, near infrared and near ultraviolet light. James Webb Telescope, on the other hand, will focus on capturing the infrared light. Advantages of capturing the ultraviolet light. Visible light is quite easily absorbed by dust cloud in the space and you lose out on a lot of information. Ultraviolet, on the other hand, passes more seamlessly through the cloud, carrying all the rich information with it. Second, as light travels over large distances, the effect of redshift pushes the wavelength of light more towards infrared side. Thus, observation of distant objects, first galaxies after the Big Bang, are more clearly visible using infrared telescopes. So clearly, James Webb Telescope and Hubble covered different aspects of the light spectrum. So truly, James Webb is not a successor to the Hubble. It's definitely a next step in how we observe the night sky, and it will work alongside Hubble rather than replace it. Alright, let's talk about the placement of the James Webb Telescope into the orbit. Hubble telescope orbits above Earth's equator at about 340 miles. For reference, ISS orbits at 254 miles, and Moon, our biggest satellite, orbits at approximately 238,855 miles. Now the James Webb Telescope, and hold your seats, is gonna orbit at almost 1 million miles. To be exact, it's 930,000 miles. And if you're wondering why it's so far away, you're not the only one. I was wondering the same. That's because of Mr. Lagrange. Lagrange points is a mathematical equation which gives out points in orbit between two masses in space which tend to stay put in their relative positions. The gravitational pull of two large masses precisely equal the centripetal force required for a small object to move with them. In this case, Sun and Earth. There are 5 such points, L1 to L5. L2 is the point which will be targeted as the orbital point for James Webb Telescope, which is on the outside of Earth in relation to the Sun and Earth at a distance of 930,000 miles from the equator. By placing the satellite all the way at L2, we'll always keep it on the night side of Earth, as in the satellite will never be exposed to Sun directly, and it will shield it from any kind of harmful infrared radiations which may interfere with the data collection. Now that gets us to the make of James Webb Telescope. It's a beautiful looking object. It feels like the starship from Star Wars. JWT has 2 primary parts, the primary mirror and the sun foil. The primary mirror is approximately 6.5 meters tall. It'll make it the biggest infrared telescope ever made. The primary mirror will be made up of 18 separate segments that unfold and adjust to proper shape after launch. The mirrors are made up of ultra-light beryllium, which is kind of next-gen technology, and then the second part, which is the biggest feature, is the tennis court size 5-layered sun shield that protects us from the harmful radiations from the sun. JWT will observe primarily the infrared light from faint and distant objects, and in order to detect these faint heat signals, the telephone itself or the telescope itself must be kept extremely cold. To protect the telescope from external sources of light and heat such as sun and even Earth, as well as heat emitted by the observatory itself, it has a 5-layered thin tennis court size sun shield which will protect it from external heat. Modeling estimates that the temperature on the sun facing side or the outer layer could be as high as 230 degrees Fahrenheit, whereas on the cool side, or where you have the main mirrors, the temperature will be approximately negative 394 degree Fahrenheit. So the tennis court size sun shield will keep it nice and cold. Needless to say, this telescope is a piece of art, and to get to fit the tennis court size foils into an Ariane 5 rocket took a masterpiece of origami, and which created all the delays in launch of the rocket. But all the issues have been resolved. The rocket is prepped and it is now targeted to launch on December 22nd. It's going to be the most exciting launch in recent history. It's going to drive all the astrophysicists and all space enthusiasts crazy. We can't wait to see all the awesome pictures which will be sent down from the JWT. Hope you all enjoy the night sky and keep your love and likes coming. See you all.